Hello, geometry kids. Today we're going to talk about what you can do with similarity now that we know what it is. So yesterday we talked about similarity, and I want to go back over some of the final lesson summaries for similarity, just because it ties in so much to what we're going to talk about today. So super quick, to show that things are similar, we have three triangle similarity theorems. And the first one is AA, which means if you can find two pairs of congruent angles between two triangles, they have to be similar. If you can't get to the point where you have two pairs of angles, if you can show that all three sides are proportional to the three sides of another triangle, then they're similar. And there's also SAS similarity, which is when you have two sides and the angle in between. Okay. To really kind of bring home this SSS idea, which is what we're going to use in today's notes, it's the idea that if I knew that this triangle is similar to that triangle, I could write an extended proportion of small compared to small equals medium compared to medium equals large compared to large. So I could say 4 is the small here, 5 is the small there. So 4 and 5 should be proportional. Let's see, medium to medium. That would be 6 here and 7.5. So 6 and 7.5. And then big to big would be 8 to 10. And if these triangles are similar, those proportions should hold. And so if I want to check that, I can just pull up a calculator, throw it in here and check it. And again, I'm going through this because it's important to what we're doing today. And I can just say, is 4/5 the same as 6 7.5, the same as 8/10, and it is. Okay, so those would have been similar triangles. All right, so now let's do the new stuff. Lola places a mirror between herself and the school building. She places the mirror 60 feet from the base of the school building and 7 feet from her feet. If Lola is 5 feet tall, how tall is the school building? All right, well, if I want to figure this out, the first thing I want to figure out is why are we even doing this with similarity? Well, I'm going to assume that she's standing straight up so that those would be a right angle. And then if you know anything about physics and science and light refraction, you should know that when light bounces off of a mirror, it bounces off at the same angle that it came in. So this angle has to be congruent to that angle. So these two triangles here, the right triangle on the left and the one on the right, have two congruent pairs of angles, which makes the triangle on the left similar to the triangle on the right, which means I can use a proportion. So I'm going to say the height on the left compared to the height on the right should equal the base on the left when compared to the base on the right. In the previous lesson, we did small to small, medium to medium, large to large. Now I'm just doing it based on positioning. Height compared to height, base compared to base. And then how do I solve a proportion? Well, when I have two fractions set equal to each other, we can solve them by doing cross multiplication and say 5 times 60 is 300. X times 7 is 7x. And then if I divide by 7 here, I can't actually write a 7 right now. Divide by 7, I am going to get 300 divided by 7 is 42.857. They said round to the nearest foot, so I'm going to say 43 feet. Ta-da! There you go. Now, one other thing I'm going to do is to tell you when you are solving proportions, okay, if you're solving proportions, you can actually set them up in many different ways. When I set this one up, I did height to height versus base to base. I could also have done it as tiny triangle and big triangle. In the tiny triangle, the height is 5, the base is 7. In the big triangle, the height is x, the base is 60. And if you notice when I cross multiply, 5 times 60 is 300, 7 times x is 7x, I end up in the same position I was before. Okay, so When setting up and solving proportions, there are many different ways to set up your initial proportion that you're going to solve to set those fractions up. You will know that yours is equivalent to the correct one if, when you cross multiply, you end up with the same thing as like the answer key, basically. Okay. I'm not going to go through how to set all of them up, but I at least wanted to show you two different options that you could do height to height and base to base, or you could do height over base equals height over base, or base over height equals base over height, stuff like that. All right, what do we have next here? Write an explanation that shows why triangle ACB is similar to triangle AED. Okay, well, ACB is this top triangle over here. And I want to know, why is this top triangle similar to the entire triangle? Well, they have an angle that's marked here. And you know what? ACB and AED both have angle A. They share angle A. So we have angle-angle similarity because angle C is congruent to angle E and angle A is congruent to itself. And you know what? I really can't call that C. I have to call it ACB. There we go. All right, so these are similar. All right, and now I'm supposed to solve for x and y, but wow, this looks a little bit overwhelming. So what we can do is we can go back to that idea of comparing one triangle to the other. In the top triangle, the left side is 3, the right side is 2, and the bottom is x. That's for this triangle up here. In the other triangle, triangle AED, the left side is 3 plus 6, which is 9. The right side is the 2 and the y, which is 2 plus y, not 2y, 2 plus y. And then the bottom is 12. The nice thing about this chart is your proportions get set up for you, and you just grab a pair at a time and say, you know what? I can solve for x and y by partnering these up. 3 to 9 equals 2 to 2 plus y. And then I can cross multiply and say 3 times 2 plus y equals 9 times 2, which is 18. So that'd be 6 plus 3y equals 18. 3y equals 12. Divide by 3. Y equals 4. Okay, so now I know y is 4. And then I can pair it up again and say 3 to 9 and x to 12 creates another equation. Now, before I cross multiplying is great. It's going to work if you have one fraction set equal to another, but sometimes you can use your noggin rather than cross multiplying. What do I mean by that? Well, 3 to 9, the bottom number is 3 times as big as the top number. In other words, top times 3 gives you bottom. That has to hold true for this side also. So what times 3 equals 12? 4. This just has to be x equals 4. What I'm really doing is saying 3/9 is a third. How many twelfths is a third? 4 twelfths. Okay. Another way to do that is to kind of use your head and say, wait a second, I know what proportions mean. They got to be equal. I could have done the same thing here. 3/9 is a third. 2/6 would have been a third. So I would have known that the bottom is 6, making y 4. And that's definitely faster than all that gray stuff I did. Although the gray stuff is delicious. Sorry, Beauty and the Beast joke there. Okay. I talked a lot on that last one. I'm going to try to talk less here and say these charts that I have created that you can create on your own is, if you know you have two similar triangles, write them out. One triangle on one row, one triangle on the other row, small, medium, large, or left, right, bottom, or whatever. However you want to name them, you can create proportions in a chart. So let me show you what I mean here. First, find all the values of the angles in the figure, then create a chart to find the values of x and y. All right, fine. If this is 90, then this would be 90 also. And if I do 90 plus 63.4, we're going to get 153.4. 180 minus that is going to be what? 180 minus 153.4 is 26.6. So that's 26.6. And hey, so is this one, which means this guy needs to be 63.4. This triangle on the left and this triangle on the right are similar because they have the exact same angles. So now that I know that those triangles are similar, I can compare their sides with proportions. So now I'm going to do that. In the left triangle, meaning the triangle on the left, the small leg is labeled as 2. The big leg is labeled as 4. And the hypotenuse, which is the one across from the right angle, is labeled as x. In this triangle over here on the right, the small leg is 4. The big leg is y, and the hypotenuse is 8.9. Okay. So now what do I do next? I just say, well, let's make proportions. Pair them however you want. I'll start with these two. 2 to 4 equals 4 to y. Well, 2/4 is a half. 4 whats is a half? 4/8 is a half. Make another proportion. 2 to 4 equals x to 8.9. All right, so, well, this is going to be a little bit harder here, so I'm going to do this one by cross multiplying. So 4x equals 17.8, right? That's what 2 times 8.9 is. And then I'm going to have to divide that by 4 and get 4.45. You just set up proportions. Small to small, medium to medium, large to large. Okay. Moving on here. The Washington Monument in Washington, D.C. is about 556 feet tall. A 3D puzzle of the Washington Monument is 48 feet tall. What is the scale factor? Okay, well, 48 inches tall compared to 556 feet tall, 48 inches, that's 4 feet. So if I want to figure out the scale factor is new divided by old. Well, the monument is definitely older than the puzzle. So I'm going to do puzzle to monument. So 4 feet to 556 feet is 4 to 556. And if I hit math frac, oops, I hit the wrong button. If I hit math frac, it'll turn that into a reduced fraction for me. 1 to 139. So the puzzle is 1/139th the size of, or the height anyway, of the whole thing. Cool. Using the same scale factor as A, what would be the size of a 3D puzzle of the Empire State Building, which is 1,454 feet tall? Okay, well, I just need to shrink that down to 1/139th the size. 1454 times 1/139th is 1454 divided by 139. 10.46. Nearest tenth would be 10.5 feet. Dang, that would be a big puzzle. Okay. Number five. Are the triangles in the diagram similar? Well, let's see. I have a triangle right here, and I have a triangle over here. And ostensibly, they should both have right angles, because I don't think I'd plant the flagpole at anything other than a right angle. And they both share this end. So yes, they are similar by AA, because they both have a right angle and the angle at the left, we'll call it. Okay? In the diagram, the large flagpole stands outside of an office building. Marcus realizes when he looks up, the top of the flagpole and the top of the building line up. If the flagpole is 35 meters tall, and Marcus is 170 meters from the building, how tall is the building? Well, let's make some proportions. So in this triangle and in this triangle, I think what I'm going to do is height to height and base to base. So height to height would be 35 to h. Base to base would be 60 to 170. And then I'll cross multiply. So I have 35 times 170 is 5950 equals 60H. Divide by 60. And that is 99.16 repeating. And that's in meters. Perfect. Last one, right? I think it's the last one. Last one. Are these triangles similar? Well, this arrow means that these lines are parallel. And if those lines are parallel, the corresponding angles would be congruent. So I see AA based on the corresponding angles. And if those triangles are similar, I know that their sides are proportional. So if I want to compare their sides here, I could say, well, left side to left side equals base to base. So the left side of the left side, I meant the right side. The right side of the small triangle is 4x. The right side of the big triangle is 12x minus 4. Because of the right side, that whole thing would be 4x plus 8x minus 4. So this is the right side versus the right side equals the base compared to the other base. Okay. And then we need to solve for x. All right, well, if I solve for x here, I have 5x times 12x minus 4 equals 4x times 12x plus 7. If I distribute, that's 60x squared minus 20x. And that's 48x squared plus 28x. And if I see an x squared in an equation, I'm going to set it equal to 0. So I'm going to subtract 48x squared. And I'm going to subtract the 28x so that this side ends up being 0. So 12x squared minus 48x. When you have a quadratic set equal to 0, one of the great ways of solving it is factoring. So I'm going to pull out a GCF of 12x. And if I divide both of those by 12x, I get x minus 4. And then I'm going to set both of those equal to 0. 12x equals 0. X minus 4 equals 0. Well, 12 times what equals 0? 0. And if x minus 4 equals 0, then x must have been 4. Well, x can't be 0. Then I'd have side lengths of 0, and that's just weird. So x would have to be 4. And that, my friends, is this lesson. Now, I don't have a lesson summary on here, but if I did, my lesson summary would be this. Create proportions using corresponding sides, then cross multiply to solve. And that, my friends, is that. I hope you are having a good day and you continue to do so. I hope nobody's crabby. My son gave me one of his sand-filled crabs. Sorry, I had to be punny. Enjoy the rest of your day, everybody. Talk to you soon.